Example 7. Find the derivative of the given function, y equals 450 divided by 18 plus 4e to the negative 5x. There are two ways to treat this. I could rewrite this as 18 plus 4e to the negative 5x all to the negative 1, and I could use the power rule and the chain rule. Or I can leave it as is, call my numerator 450, understanding that my numerator derivative is going to be a 0. My denominator is 18 plus 4e to the negative 5x, so my denominator's derivative is negative 20e to the negative 5x. That's because it's 4e to the negative 5x times negative 5. So my derivative of y with respect to x is, remember the rule, denominator, numerator prime, numerator, denominator prime, denominator squared. So denominator has more than one term, so I'm going to keep parentheses around it. Derivative of the numerator, 0. We expected that to happen. Minus the numerator, 450. Derivative of the denominator, negative 20e to the negative 5x. All of that is over the denominator, 18 plus 4e to the negative 5x, all squared. So this being multiplication by 0, this whole thing is 0. So I'm going to be left with negative 450 times negative 20. That's going to be 9,000, positive, because a negative and a negative, right? So 9,000 e to the negative 5x, all of that divided by 18 plus 4e to the negative 5x, quantity squared. Now doing it the other way, by rewriting it, y is 450 times 18 plus 4e to the negative 5x to the negative 1, I'll get dy dx is constant times the power times the base to the power minus 1 times derivative of that base, negative 20e to the negative 5x. And so we end up with a negative 450, a negative 20 e to the negative 5x, and because this is a negative exponent, that's a negative 2, this whole base, 18 plus 4e to the negative 5x, will go to the denominator with a positive exponent. And then simplifying my numerator, negative 450 times negative 20 is positive 9,000 e to the negative 5x divided by 18 plus 4e to the negative 5x, all squared. So you'll notice we get the same answer regardless of using the quotient rule or the power rule, but you would have to know to use the power rule that this denominator has to be moved to the numerator with a minus 1 exponent. Example 8. Find the derivative of the following function, y equals 9 to the 8x plus 5. So in this case, we have a base that is not the e base. Remember, e is just a number like pi, but it's about 2.7. We have a base here of 9, so our derivative is different. When we take the derivative of a function, f of x equals a to the x, where a is not e, f prime of x is a to the x times the natural log of the base a. If the exponent is a function, you must also tack on the derivative of the exponent. So the derivative for y equals 9 to the 8x plus 5 would be dy dx is, copy the function, 9 to the 8x plus 5, times the natural log of 9, the base, and it's best to put parentheses around that, times the derivative of the exponent, which is 8. It just makes it clear that the 8 is not inside the natural log. Now, any way you write this, you're going to need to put those parentheses around that natural log. You could put 8 in the front times 9, 8x, 9 to the 8x plus 5 times the natural log of 9. You wouldn't need it then, but be careful. Don't multiply those two numbers. Those don't get multiplied. So either of those is fine. Just make sure that you make it clear that there's nothing in that natural log other than that 9.